So let's begin. Let's first scratch out that top part. It's not supposed to be, that's a typo. This is actually notes section 4.4. Okay. So what is the square root? Why does the square root of 9 equal 3? Because 3 squared is 9, right? We know that a square root is the opposite of a square, and a square is the opposite of a square root. Okay. So what if I asked you what's the square root of negative 9? Well, the answer is not 3 because 3 squared is positive 9, and it's not negative 3 because negative 3 squared is also positive 9. So whenever we have a negative inside a square root, that's when you don't have a real answer. That's when you have an imaginary answer. Okay? So we need to understand this fact right here, that whenever you have the square root of a negative, you can't have a negative in there. That becomes an imaginary answer. So the square root of negative 1 is I. Okay, the square root of negative 1 is I. So, like if I asked you what's the square root of negative 9, well, this is the work that should happen. You rewrite it as the square root of negative 1 times the square root of positive 9. That way you know the square root of negative 1 is what? I. And the square root of 9 is what? 3. So you really have I times 3. And it's just like I is like x, it's just a variable. I times 3 is 3i. So whenever you have a negative in a radical, in a square root, you're going to end up with an imaginary value, okay? So let's jump to this right here. So this is the reason right here. The square root of negative 1, that's really I. And we know that I equals I. Duh, of course, x equals x, an apple equals an apple. Now, what is I squared? Let's think about this. If I is the square root of negative 1, if I were to square this, all right, if I were to square this, what would happen to the square root and the square? Come on, people, wake up. What would happen to the square root and the square if I were to square it? Cancel out. What would your answer be? Negative 1. So it's safe to say that I squared is negative 1. So I squared is negative 1. Everybody box this in, highlight it, put some stars right next to it. I don't know. Just make sure that you have this memorized. As a matter of fact, turn to somebody right now and tell them, hey, I squared equals negative 1. That's exactly right. I squared equals negative 1. Okay? So I is going to be like any other variable. Like if I said, what's 2x plus 3x? What's the answer? 2x plus 3x. What's the answer? 5x, right? What's 2i plus 3i? 5i. It's the same math going on, right? The only difference is that if you ever have an I squared, you're going to have to change it to a negative 1. Because an I squared goes back to a regular real number, a negative 1. Okay, anyway. So what would I to the third be? This is where it gets a little interesting. Well, we already know that I is I, and it's just like a variable, like an x or a y or an a or a b. And we already know that I squared is negative 1. So since we know both of these, why not rewrite this guy as both of these? So this is what I want you to do. Let's rewrite I to the third as I squared times 1 more I. Now, what is I squared? You just told somebody, right? I squared is negative 1. So what I really have here, instead of I squared, I really have a negative 1 times that I. And what is negative 1 times I? That's negative 1i, or just negative I. So there's your answer right there. I to the third is really negative I. No, just negative I. I squared is negative 1, but I to the third is really I squared times another I, which is negative 1 times I, which is really just negative I. I to the fourth. I to the fourth. I could rewrite I to the fourth as what? Yeah. I squared times I squared. That's the easiest, best way to do it, right? I to the fourth is really I squared times I squared. Now, why would I write that? Because I know that I squared is really what? Negative 1. So I really have negative 1 times negative 1, which is 1. Do me a favor. Box this guy in. Put some stars, whatever, highlight. As a matter of fact, turn to somebody right now and tell them I to the fourth is 1. I to the fourth is 1. Okay, how about this? Tell them I squared is what? I squared is what? Negative 1. I to the fourth is 1. Okay, if you memorize those, you're good. This is going to be cake. So there's a picture on the board, right? And let's continue with this. Now, we already said that I is just I. I squared is negative 1. I to the third, well, that's I squared, which is negative 1 times another I. That makes it a negative I. I to the fourth is really I squared times I squared, which is 1. And if you memorize that I to the fourth is 1, everything else becomes easy. Because what would I to the fifth power be? That would simply be, what's the easiest one that you know? I to the fourth is what? 1 times 1 more I, right? So that's really like a 1 times I, which is I. Okay, what would I to the sixth be? Let me do it in red. I to the sixth would be, what's the easiest one you know? I to the what? I to the fourth times what? I to the fourth times what? I to the second. And what is I to the fourth? And what's I to the second? Negative 1. So you really have 1 times negative 1, which is what? Negative 1. Now, how about I to the seventh? What would that be? Let's rewrite it as what we know. What's the easiest one you know?
4.
I to the fourth. I to the second. And so far that's 6, but we need 1 more, right? So times I. So what is I to the fourth? What's I to the fourth? That's 1. What's I to the second? Negative 1. So you really have 1 times negative 1 and then times 1 more I, times 1 more I. So what's your answer going to be?
Negative 1I.
Negative 1I, or just negative I. Do we notice anything here? Pattern. I, negative 1, negative I, 1, I, negative 1, negative I. What would I to the eighth be? I to the eighth. 1. Okay, so if I go I to the eighth, that's really I to the fourth times I to the fourth, and each of those are 1, so your answer is 1. So check this out. It's really amazing because knowing that fact that I to the fourth is 1, you could answer anything. What's I to the 40th? See, 40 is divisible by 4, right? So you know you're going to have I to the fourth times I to the fourth times I to the fourth times I to the fourth, and there's not going to be anything left over. So what's your answer to I to the 40th? 1. What's your answer to I to the 20th? 1. What's the answer to I to the 24th? 1. Easy, right? How about this? What if I asked you, what's I to the 36th power?
All the way by 2. Oh no, that's 1.
That's 1 also. What if I said I to the 37th power? What? Sorry, hold on. I to the 37th power.
Oh, negative 9.
Well, if you divide this by 4, will you have a remainder? Yes, because it doesn't go in easily. What's your remainder? 1. So you just have an extra I left over. So I to the 37th is really I. Are you guys getting that or no? No? Okay, we got lost. How about this? Oh, dang. I just deleted everything. Wait, oh no, wait. I'm sorry. Hold on a second. How about this? If I told you I to the 42nd power. Let's start with something easier. Instead of 42nd, let's say I to the 10th, yeah? I to the 10th. What could you rewrite that as? What's nice? I to the what is nice? I to the fourth times I to the fourth. And then, of course, you have 2 more I's left over, I to the second, right? Because 4 plus 4 is 8. You have 2 more to get to 10. So knowing that I to the fourth is 1, it's kind of like if you divide this by 4, think of your remainder, and then that'll tell you how many more I's you actually have to think about. All right? So what's the answer to I to the 10th? It's just negative 1. Why? Because 1 times 1 is 1, but that's a negative 1, so there's your answer, negative 1. So if I say, what's I to the 41st power? Well, we know that if we divide that by 4, it'll go in nicely, and you're going to have a remainder of what? Just of 1, which is I, right? So check this out. I could say I to the 40th, that's going to be 1, times 1 more I to make it 41 total. So what's your answer? It's just going to be I.
So every odd number is going to be I?
No. Think about it as dividing by 4. Look, watch. Give me any number you want. Any number. I to the what? 68th power. That is divisible by 4, isn't it? So what's the answer? 1. Okay. Now, what if it would have been? How about the 71st power? All right. Let's change that to 71st. I to the 71st power. Well, okay. Sorry about that. Check this out, guys. If you take your calculator and go 4 times what gets you close to 71 without going over, right? 4 times 17. 4 times 17 is what? 68. How many more do you need to get to 71? 3. So you could rewrite this as I to the 68, which is just 1, times I to the 3rd, which would get you back to the 71.
Just write 3 I. Oh no, I to the 2nd times I.
And then you really got to just think about that guy, which is I to the 2nd times I. And what is I to the 2nd? And then times I. Negative I is your answer. I know you guys are thinking, I. Why what? It's not Y, it's I. Okay. Ladies and gentlemen, let's go for these. A little more basic. What's I to the 5th? If you divide it by 4, how many more do you need to get to 5? 1 more, right? Like it goes in, 4 goes in 1 time with a remainder of 1. So you really have, show your work, I to the 4th times 1 more I. So what's I to the 4th? 1. And then 1 times I is just I. So there's your answer for number 1. How about number 2? What's the answer going to be? Just 1. Remember, if it's divisible by 4, then you're going to be able to rewrite it as I to the 4th times I to the 4th, which is going to be 1 times 1, which is 1, right? Okay. How about I to the 6th? That's going to be a negative 1. Now, how do we get that? Well, think about this. If you had I to the 4th times I to, you need 2 more. This is 1 times negative 1, so that's negative 1. I to the 10th. Okay, you're going to rewrite it as something divisible by 4, and then 2 more, right? So this is 1, and this is negative 1, so that's going to be a negative 1 again. Yay? All right, how about this? Right here on this spot. Just get this one, and I'm good. Let's call it number 5, and we're going to say I to the 25th power. What's the answer to I to the 25th power? I. Why is that? Because 24, I to the 24th is 1, and you need 1 more, right? So I to the 24th is 1, and you need 1 more, so that's just 1 times I, which is I. So I to the 25th is just I. Okay? Let's go through some examples here. Number 2, what's that answer? Number 2. That's just I. See, and this is really not something that, this is the explanation of where imaginary numbers come from. The I comes from a negative square root, or the square root of a negative. Now right here, what's the answer? Negative 1. You could think of this 2 different ways. You could say, oh, this is really I, and I squared is negative 1. Or you could say that the square root and the square eliminate themselves, and that's your answer, negative 1. How about number 4? What's the square root of 64? And what's the square root of negative 1? I. So 8 and I is 8i. Check it out. Let me show my work here. Instead of negative 64, let's rewrite it as negative 1 times 64. And when you split that root, yeah, the square root of negative 1 is I, and the square root of 64 is 8, and we are multiplying them together. And like I said, I is just like any other variable. So if you had x times 8, do you leave it x8? No, you change it to 8x. So I times 8 is 8i. So there's your answer for number 4, 8i. Good. Let's solve. How do we get rid of that square? Square rooting. Square rooting. Now remember, when you apply a square root in an equation, you must put a plus or minus in front of your answer. However, let's show our work to the square root of negative 75 up here. You're going to split that to negative 1 times 75. And we know that the square root of negative 1 is just I. And 75, you could rewrite it as 25 times 3 to get a perfect square number. That way when you split it, you'll have the outside I that came from the negative 1, square rooting it. And you also have the 5, and the square root of 3 is going to stay. But the correct order for that would be 5i square root of 3. So the final answer is x equals plus or minus 5i square root of 3. And it has to be in that order. The real number first, imaginary variable second, and the square root at the very end. That's your answer for number 1. Okay, you guys are freaking out, but there's nothing to freak out about, right? We've already solved applying square roots, right? We've already simplified the square root of 75. It's not a perfect square number. You rewrite it to get a perfect square number with multiplication. The only difference is now you have a negative, and what happens with this negative, it just pops out as an I. Simple as that. The square root of negative 1 is I. Look, let's do a couple more.
Wait, I have a question.
Yes.
Every time there's a negative, it turns into an I?
Anytime there's a negative inside a square root, you got to get rid of that negative and make it an I on the outside. Okay, it's that simple. Huh? Can you make it what?
Another variable.
Okay, I is not confusing at all. It's just like X.
Okay, can you just turn it into X?
No, it has to be I.
Has to be?
Yeah.
I.
So let's take a look at number 2. What do I do? Add 7. Add 7. Rewrite. 3x squared equals what? Negative what? 24. What's my next step? No, you got to isolate it first. Get rid of the multiplication of 3 out in front. Divide by 3. Divide by 3. Now we have x squared equals negative 8. What do I do next? Square root. Square root. X equals, you need a plus or minus in front of your answer, but now we need to simplify the square root of negative 8. Now your Casio calculator can't do this, so please pay attention, please understand and be able to do it. So yeah, when you think of the square root of negative 8, let's do this right here on the side. You're going to rewrite it as negative 1 times 8, and you're going to split the root. The square root of negative 1, that's just I. The square root of 8 becomes 4 times 2 and split the root again. The square root of 4 is 2 and the square root of 2 stays. You have I out in front. So you really have I times 2 times the square root of 2. Let's rearrange it in the order that we need it to be. Real number first, imaginary variable second, square root value at the end. So there's your answer. X equals plus or minus 2i square root of 2. What do you think? It's not difficult, guys. Stop saying that it's difficult, because it's not. What if I told you find the roots? What does that mean? Find the roots. Get the answers. Or x-intercepts or solutions, right? It all means the same thing. So if I give you this function to graph, it'll be a parabola opening up. We could find the vertex if we wanted to, but right now they want us to find the roots, the x-intercepts, the answers, the solutions. How do you find the x-intercepts? You set y equal to 0. So you're really going to have 0 equals this stuff. So you could have 0 equals, or you could have this equals 0. It's totally up to you. But you end up with that equation that you need to solve, either equal 0 over here or equal 0 over here. I prefer it on the right side, so I'm just going to erase the left side of it. And then you solve the way you always do. Plus 4, you're going to have x squared equals 4. You're going to square root, x equals plus or minus 2. No I. No I involved because there was no negative inside of the root. But if we take a look at another one, like let's say number 3, if you want to solve this thing, you're going to divide by negative 3, divide by negative 3. You have x squared equals negative 8. Square root. You will have x equals plus or minus. And right here, the negative 1 becomes I on the outside times the square root of 8. You're going to rewrite that as 4 times 2. Split the root, and you have 2 square root of 2. Let's rearrange it the way we need to. X equals plus or minus 2I square root of 2. So all you got to remember is that when you take the square root of a negative, the I appears, and the negative inside disappears. Would you like to see any other ones?
Yes.
4, 5, or 6? Pick one. 6. So add 14. Add 14. What do we get? 23. So we're going to end up with negative 4x squared equals 23. Then what? Divide by negative 4. Divide by negative 4. This is going to be ugly. Cancels. X squared equals 23 over negative 4. Now, how do we get rid of the square? Square root. So you will have x equaling plus or minus. You're going to split the root to the 23 and to the negative 4. And what's the square root of negative 4? 2i. So we really have plus or minus square root of 23 up on top with the 2i on the bottom. Now, let's come back to this answer later because it's not written correctly. We need to be able to write it as a complex number that has a real part and an imaginary part. But we'll come back to that later. Let's jump over here right now to this next section. This next section is easy if you're paying attention. Okay, a complex number written in standard form has a real part and an imaginary part. So you're always going to put your real number that's by itself first and your I value second. Okay, how do you treat the I variable? You treat it like any other variable. But the only thing you have to remember is that I squared is really negative 1. So if you ever end up with an I squared, you must replace it with negative 1. Example, everybody look at number 1. What if I asked you what's 3x times 2x? What's the answer to 3x times 2x? 6x squared, right? So in this case, what's 3i times 2i? 6i squared, right? But what do we know about I squared? I squared is really negative 1. So yeah, you have 6 times negative 1, which the answer is negative 6. Let's take a look at number 2. What's 3i plus 2i? 5i. You don't mess with exponents when you're adding or subtracting. Right here. 3 times that complex number. It has a real part and an imaginary part. So what's your answer going to be? 12 plus 6i. You just treat it like if it were a regular x, right?
So that's it.
But whenever you have an I squared, you got to change to a negative. Negative 1. Because I squared equals negative 1.
Oh, I get it.
So you just treat it like a regular x, but if you ever end up with the I squared, replace it with a negative 1. Because we know that I squared equals negative 1. So let's distribute right here. Negative 3i times negative 5. What do I get? 15i minus 6i squared. But what is I squared? It's a negative 1. So what I really have is 15i minus 6 times negative 1. So what I really have is 15i plus 6. And we need to write it the way they tell us to. Complex numbers have the real part first and the imaginary part second. So what do I write it as? 6 plus 15i. That's the answer. Again, it's the same thing as if you had like negative 3x times negative 5x or negative 5 plus 2x. The only difference is that when you end up with the x squared, you have to replace, well, the I squared with a negative 1. Too easy. You're not going to end up with an I squared. So all you got to do is distribute that minus sign, change it. You'll have 4 plus 2i minus 3 minus 5i. So you want your answer with the real part first, so do the real numbers. What's 4 minus 3? 1. And then do the imaginaries. What's 2i minus 5i?
Negative 2i. I mean 3i.
Negative 3i. There's your answer. These are fun right here. Go ahead. Try to do it. Just remember that an I squared you have to replace with the negative 1. Let's distribute one at a time. Let's go 1 times 3, that's 3. 1 times 4i, that's positive 4i. Now let's distribute this positive 2i. 2i times 3, that's a positive 6i. 2i times 4i, that's a positive 8. I times I is I squared. So whenever you see that I squared right there, you need to remember that the I squared is really what? Negative 1. So what we really have here is after combining the like terms, the 4i with the 6i, we have a 10i right there, positive 10i. We also have a 3 out here in the front, and we really have the 8 times negative 1. 8 times negative 1 is what? Negative 8. So I really have a negative 8 right here. So I have 3 minus 8 plus 10i. What's 3 minus 8?
Negative 5.
Negative 5. Plus 10i, you can't really combine it. They're not like terms. There's your answer. You want your real part first, your imaginary part second. Number 7 is super fun. I love number 7. Does anybody have an answer for number 7? 13 is the answer. How do we get that? Check this out. 3 times 3 is 9. 3 times negative 2i is negative 6i. Positive 2i times positive 3, that's a positive 6i. Positive 2i times negative 2i, that's a negative 4, but then I times I is I squared. We know that I squared is really a negative 1, right? So I really have a minus 4 times minus 1 right there. Might as well do that. What is a negative 4 times a negative 1? That's positive 4. And how about negative 6i plus 6i? Eliminates. Bring down the 9. You have 9 plus 4, which is 13. Now, why do I like this one? Because the i's got eliminated. Okay. Now, what could you observe about both of these binomials? What could you tell me about both of these binomials?
2i is plus and then negative, and then there's negative 2i.
Yeah. They're identical. There's a 3, there's a 3, there's a 2i, there's a 2i, but one's a plus 2i, one's a minus 2i. Now, there's a vocab word for this. It's called a complex conjugate. Okay. The word complex conjugate is simply taking your binomial that has a real part and imaginary part and changing the imaginary part of it. Not the whole thing. It's not like saying, oh, this is a positive, this is a negative 3. No, that's incorrect. It's just the imaginary part has to be opposite. Same identical binomial, but a sign change in the middle. That's what we call a complex conjugate. The conjugate of a plus bi is a minus bi. Practice. Please state the complex conjugate of the following. Number 1, what would the complex conjugate be? 3 plus 2i. What would be the complex conjugate of number 2? 5 minus i. If you're thinking, where the heck is he getting this from? All I'm doing is changing the sign of the imaginary part. The real part, I'm leaving it. I'm rewriting it. And I'm just changing the sign of the imaginary part. So you should be able to do all these nice and easy. This one's 0.5 plus 4i. This one's negative 3 plus 7i. So once again, we're only changing the imaginary part, not the real part.
You end up with 2 negatives.
That's okay. So like on number 5, you're going to leave that negative 2 out there in the front, but you're going to change that positive 6i to a negative 6i. Now, we're not even doing any math here. I'm just stating that you have to change the imaginary part, not the real part. So number 6, is there a real part? No. You could imagine that it's a 0, right, in front. But if you change the imaginary part, what's your conjugate going to be? 3i, positive 3i. Now, How about number 7? Your answer is just going to be 9, or your conjugate is just 9. Why? Because there's no imaginary part, and the complex conjugate is changing the imaginary portion of it. Okay, so why am I having you practice the complex conjugate? Because if you ever have an imaginary value in the denominator, you have to get rid of it. And how do you get rid of it? By multiplying by that complex conjugate. Okay, so everybody go to number 1, and let's multiply the bottom by the complex conjugate, which would be what? 1 minus 2i. But on a fraction, you can't just magically multiply the bottom by something. You have to do it also to the top. So let's multiply the top also by that same identical value, 1 minus 2i. So we have a lot of math to do here, all right? This is probably as challenging as it gets, but it's pretty easy. Up on top, I'm going to, or should I do this? There's hardly any space, but here we go. 3 times 1 is 3. 3 times negative 2i is negative 6i. That's what we have on the numerator. Yay?
Yeah.
You know what? I want to put a little cloud around it. I want to put an N for numerator right there. On the bottom, we have a lot of work to do. We're going to distribute. So I'm going to ignore the answer up on top for a little while. 1 times 1 is 1. 1 times negative 2i is negative 2i. And then positive 2i times 1 is a positive 2i. Then a positive 2i times a negative 2i is a negative 4 with an I squared. Now we should remember that I squared we need to replace with a negative 1, correct? What about these middle values? What happens to the negative 2i and the positive 2i? Cancel out, okay. So I really have the 1 that's out in front. And what do I end up with back here? I have a negative 4 times a negative 1. What's negative 4 times negative 1? That's actually positive 4, right? So on the bottom, what do I really have? 5. So let's rewrite our fraction now. We have the 3 minus 6i up on top. 3 minus 6i up on top over 5. Now, we think that that's our final answer, but it's not, because a complex number has to have 2 parts, a real part and an imaginary part. So we need to split. This is one single fraction. Let's split it into 2 fractions. So splitting it into 2 fractions is simply taking that denominator 5 and putting it on each of them. So you'd have a 3/5 minus 6/5 with an I. That's your final perfect answer. Is it a lot of work? Yes. Is it easy? Only if you practice. If you practice, it gets easy. I don't know. Let's take a look at number 3. You guys could do number 2. Let's look at number 3. What am I going to multiply both top and bottom by to get rid of that I? Again, you don't want to leave i's in the denominator. So if you're ever doing math and you get this as an answer, you have to get rid of this I at the bottom. How do we get rid of an I? By multiplying the whole denominator by what? By the conjugate, by the complex conjugate. And what is the complex conjugate? You just change this middle sign. Everything stays identical, change the sign. You guys remember when we multiplied a binomial times a binomial and it was the same exact thing, and one's plus, one's minus? The middle terms cancel out, right? That's why we have one positive and one negative. So anyways, what we do to the bottom, we do to the top. And this is like doing 2 separate problems, actually 3 separate problems. Up on top, let's distribute, and we really don't have any space, but write really small, I guess. 1 times negative 3 is negative 3. 1 times negative 2i is negative 2i. And then positive 2i times negative 3, that's a negative 6i. Positive 2i times negative 2i, that's negative 4 with an I squared. Now we still need to combine like terms, change I squares to negative 1s. So let's do exactly that. Combining the negative 2i with the negative 6i, what do I get? Negative 8i. And over here, the I squared is really a negative 1. So I really have a negative 4 times negative 1. What's negative 4 times negative 1?
4.
That's positive 4, right?
Yeah.
So I just wrote it down right there. And this negative 3, I'm just going to bring it down right here. So what do I have left? I have this negative 3 that I could combine with this positive 4. And what do I get? I get 1, yes? So I really have negative 3 plus 4, that's 1. And then minus 8i. This is the numerator. The numerator right there. Let's go down and simplify and get the denominator after multiplying by its conjugate. So we're going to have negative 3 times negative 3, that's positive 9. Negative 3 times negative 2i, that's positive 6i. Then we have positive 2i times negative 3, that's negative 6i. Positive 2i times negative 2i, that's negative 4i squared. We already know the middle terms cancel out. After you do this so many times, you'll be able to skip those multiplication of the middle values because they're going to cancel out. But anyway, I squared is really a negative 1. So you really have a negative 4 times negative 1. So what we really have here is 9 plus 4, because a negative 4 times negative 1 is positive 4. 9 plus 4 is 13. So this is our denominator. Okay, so we go back, get our numerator, put it on top of our denominator, and then split the fraction. So up on top, we have a 1 minus 8i. It's over 13 on the bottom. And now we need to split that into two parts, the real part and the imaginary part. So your answer is 1 over 13 minus 8 over 13 with the I right next to it. It's a lot of work. We're not going to learn anything else, okay? This last one, you could multiply by the conjugate, or if it's not a binomial, you could simply multiply by I. Check this out. If I multiply by I, both top and bottom, up on top, when I distribute, I'll have 3i plus I squared. And we already know that I squared is really a negative 1. But that's the top, right? Let me actually rewrite that top. You're going to have, this is really negative 1. So you're really going to have a negative 1 plus 3i up on top. And on the bottom, your I times I is I squared. So you have negative 3i squared, which is really a negative 1, which is really a positive 3. And then you split that fraction into 2. You'll get negative 1/3 as your real part, plus 3 over 3 with the I. And of course, 3 over 3 is really just 1. So your final answer is 1/3 is your real part, plus your regular I, your second part. So that'd be your answer to that one. This is a ridiculously long video, long lesson. The quiz on Thursday, half of it's going to be from this page, right? The other half is factoring, stuff we did before. We do have a homework assignment, ladies and gentlemen. It's page 250, 1 through 8 all, and 11 through 41 odd. So on Edmodo, I'll have this picture, which is a picture of the page. You guys could actually start it right now. Copy down 1 through 8 and start doing it. That's the assignment, 1 through 8, and then 11 through 41 odd. So it's just simple, like what's the square root of negative 81? What's the answer there? That's 9i. 9i, right? A negative is imaginary. How about multiplying? Oh, 4 times negative 3, that's negative 12. I times I is I squared, which is negative 1. Negative 12 and negative 1 is positive 12. So the answer number 3 would be 12, right? How about the answer number 5? That's just 1. Yeah, I to the 40th. It's divisible by 4, so that's just 1. And we're going to be skipping down to 11 through 41 odd. So 11's easy. Just combine like terms, distribute. And we're doing all these. So everything will be on Edmodo. Make sure you do this for homework. Okay, so in case you don't have access to Edmodo, you could just pause the video right here and copy down 1 through 8. And then you could pause the video right here, copy down 11 through 15. And then pause the video right here. We're doing the odd ones, 19 through 33. So copy those down. Hit pause, copy them, and then I'll scroll down to the last few. hit pause and copy down 31 through 41 odd right there. And remember that on these last 37 through 41 odd, we're solving. It says solve each equation. So again, get x by itself, and you probably end up with a negative when you square root, which will give you an imaginary.